All right, welcome everybody. Hello, hello. Let's do this. So let's continue our journey of trigonometry. Here, what are we asked to do? We're asked to find sine of 120 degrees and cosine of 120 degrees. But before we go into this question over here, let's have a quick little review of lesson 1 and 2. And what I'd like you to do is take out your notes and just try and do this as a do now, very quickly. When was the height positive or negative, and when was the coheight positive or negative? So don't remember that height talks about going up and down, and coheight talked about going left and right. What I want you to do is try and answer the do now. Okay. So let's take a look. Here, if we were in these quadrants, we knew that height talked about the y, and coheight talked about the x. So when is y positive? Y is positive in quadrant 1 and 2. So here we know the height is positive above the x-axis, and we know height is negative below the x-axis because height is talking about the y values. Coheight was positive in quadrant 1 and quadrant 4 because the x values are positive here. And here, the x values over here will be negative. So and please have this in your notes, it'll be very important. Here, there is a connection between height and sine and a connection with coheight and cosine. The idea is height and sine will be the same idea, and coheight and cosine will be the same idea. Because let's say if I have a circle here, right? And okay, that's really bad. Let me try over here. Let's say if I have a circle and I have this point over here. If I wanted to find the height of this point, what do? What's the value of the height of this point? It's from here to here. This is height because we're talking about up and down. If I'm talking about coheight, what is the value of coheight? It'll be here to here. Or I could say it's here to here. And the same thing with height. Height could be here, but what's the same value of this will be this. And if I say coheight, it will be this, but it has the same value as that. Okay? So what on earth am I talking about, and why will this be important? We'll find out very soon. Okay? So let's try and do this problem. Here it's saying, suppose that point P is on the unit circle obtained by rotating the initial ray for, oh, this is weird. It says 150. Okay, fine. We can make it 150. 150 degrees. Here, actually, no, I'm sorry. Let's make it 120. It should be 120. Okay. Here, so let's rotate 120 degrees. Notice that this is the initial. Now, if I rotate 120 degrees, which quadrant will you be in? So let's just be a little bit organized. Let's write our degrees. This is 0 degrees, 90 degrees, 180 degrees, 270 degrees. So notice that if we say 120 has to be between 90 and 180. So we say that this angle is somewhere over here, and we know that this is the theta, right? This is our theta, our rotation. We know this is 120 degrees. But if we wanted to calculate what is sine of 120 degrees, how do we do that? Previously, we had our special triangles, right? What were our special triangles? They looked something like this. Now, how do we find sine of 120 degrees? The connection with sine and height, when we talk about height, what is the height of this point P? If we were to find the height is the distance from here to here. But watch what is going to happen, because when we find sine, we're actually going to be finding the height. And let's see how this actually works. So let's say if we have this triangle over here. Now, if you practiced your delta math, what is the reference angle over here? And if you need time to take a second, what do we mean by reference angle? Take your time. Okay, get your notes. Remember, reference angle is the angle in between the terminal ray and the x-axis. So what is this angle in between? If you know this angle is 120, what does this angle over here have to be? And let me make the triangle, let me draw it over here. What does this angle have to be? It has to be 60 degrees. Because if this is 120, what's in between 120 and 180? This angle has to be 60. So what else do you know about this triangle? You know that the distance from here to here has to be what? It has to be 1. Why is it 1? Because we have the unit circle. And what else do we know? If we know this, does this look very familiar if we have this triangle right now? Notice which one of the 3 triangles are we using? We're using this one here. Notice what is opposite of the 60? It's square root of 3 over 2. So notice the same idea here. What is opposite of this 60? It is square root of 3 over 2. And what's adjacent? It'll be a half. So then how does this help us actually find what sine of 120 is? Notice sine of 120 is just this distance. If you want to say, oh, mister, we have to do, opposite over hypotenuse, sure, go ahead and do that. But notice what's the opposite? It's square root of 3 over 2. And what's the hypotenuse? It's 1. So divided by 1, it's just this. So notice that sine is calculating what we were doing before with height. It's the same idea we had with the Ferris wheel. If I could find it right now. No, I can't find it. But that's the connection between height and sine. They're going to be the same thing. Now notice this square root of 3 over 2. Is the value positive or negative? Notice that height is positive. So what is that going to mean about sine? We know sine is going to be positive in quadrant 2. Let's see what happens when we go for cosine. So notice cosine of 120 degrees. Now that we have our triangle, what's adjacent to this 60 degrees over here? It's just adjacent over hypotenuse. But notice that the hypotenuse is always 1 because we have that unit circle. So now it just becomes a half divided by 1. But then what's the next question you ask yourself? Is cosine positive or negative over here? And cosine has to be negative over here because the co-height is negative over here. There's that connection between co-height and cosine, okay? Cosine is going to take the x values and sine is going to take the y values. So the same thing that we had over here with height and co-height, we're going to have with sine and cosine. So when is sine positive? Sine is positive, the same position where height is positive. So it's going to be positive here and here. Where's cosine positive? Where's cosine positive? Cosine positive is here and here. Where is cosine negative? Here and here. And where is sine negative? Here and here. Okay, and it's going to represent the same idea. So this idea over here, this cosine of 120 is negative a half. Okie dokie. What I want you to do is, this was for 120. What I want you to do is same exact question. Try and do it for sine of 135 degrees, cosine of 135 degrees. And then what I want you to also do is do sine of 150 degrees, cosine of 150 degrees. Notice you have to take your time. Which one of these triangles will you get when you find that reference angle? Okie dokie. Let's see. So we'll do these questions in class tomorrow. Okay, so try and do them on your own. And try and do for homework. Okay, let's try and find the next one. Here, that was what, page 3? Is there a page 4? Oh yeah, page 4. Oh, page 4 asks you to do 150. And if you look, oh, I'm sorry, let's look at page 4. Notice we have this discussion. It's just basically this. What this is asking you to do is, whatever this is, boom. Like just have this over here. You know, like sine is positive above the x-axis, sine is negative below the x-axis. Now try and do this question of sine of 150, cosine 150. Let's do it together. Okie dokie. I'm not gonna lie, I am pretty tired. It's been a long day. Alright, so this is the last question for me today, and then I'll make another one tomorrow. But how do you do sine of 150, cosine 150? Okay, so what's the first move? Let's draw the coordinate plane. Let's draw a beautiful circle. Okay, that wasn't too bad. Now notice, let's write our degrees: 0 degrees, 90 degrees, 180 degrees, 270 degrees, okay, 360 degrees. Now what's the question asking? It's saying, what is sine of 150, cosine of 150? So we have to rotate. So we start at 0, and we're gonna rotate. 150 should be somewhere here, okay? So boom. So notice that this is what we say, this is the initial ray. Okay. Then what do we have? We have some terminal ray like this. Okay. Now, we need to find the reference angle. Okay. And if you feel like you're shaky on that, that is no bueno. You have to be good with it. How do you find the reference angle? What's the first move? Put a point on the intersection of the terminal ray and the unit circle. Okay, so where's that point? It's right here. Then what was the next move? Draw a line from the point up or down to the x-axis. So we just draw that point here. Notice, what is the angle? Notice if this is 150 degrees, what does this angle over here have to be? This angle has to be 30 degrees. Okay, this is your reference angle, or your, what was that symbol? This is your phi. Right? Your phi is your reference angle. Okay, so if you know this is 30 degrees, what else do you know about your triangle? Yeah. So, okay, my bad, that was a terrible triangle. Okay, that's a little better. So you know this is 30 degrees. What else do you know? You know that the distance from here to here is 1. Why? Because you have that unit circle. And then what else? Notice which one of your triangles looks very familiar here. That's why these triangles are important. We have a 30, 60, 90 triangle. Notice what's opposite of the 30? It's a half. So what's the opposite of this 30? It's a half. And what's over here? Square root of 3 over 2. So notice when you talk about the sine, what is sine calculating? It's calculating this. This is sine. And here, this will be what? This over here, this will be cosine in the pink. Okay? I'm sorry, the colors look all botched up right now, but this is the sine and this is the cosine. So notice what's sine of 150? It's a half. Now ask yourself, positive or negative? It has to be positive. Sine is positive in quadrant 2. This cosine, what is it? It's square root of 3 over 2. Positive or negative, it has to be negative. Okie dokie. Okie dokie. I hope that was fun. What I want you to do is try and do the rest by yourself. I am pretty exhausted right now, so I'm not going to continue. I'm going to have a nice dinner. Try and do sine of 240, cosine 240. Sine of 330, cosine 330. Notice which quadrant will this be in? Which quadrant will this one be in? For homework, what I want you to do is try and find, like, you really have, like, the basic of trig is you have to be solid with this. In pre-calculus and AP calculus, you have to know these rapido. Okay, so what I want you to do is take your time, but I want you to find sine of 120, cosine of 120. Sine of 135, cosine of 135. Sine of 150, cosine 150. I want you to find sine and cosine for all of these. And when you actually do these by yourself, you're going to get really good. and you're gonna see, you'll see me if you want. I can do these with my eyes closed, and I'll show you in the video lesson tomorrow, or I'll do it live. And when you're in AP Calculus, you have to do these with your eyes closed. But you'll get to that point. For now, just try and find it on your own. Okay, happy face. Enjoy your day.